So this question says a person is paid $50,000 a year in 2020. Assuming they get a 3% raise every year, how much will they earn in 2023, and in what year will they earn at least $60,000? So let's do some analysis here. If the year is 2020, they earn $50,000. In 2021, they earned $50,000 plus 3% of $50,000, which is the same as 1.03 times 50,000. So 2 years after 2020, so 2022, 2020 plus 2, they get the 50,000 times 1.03 times another 1.03. To get a 3% raise, you take your current value, our current one is 50,000 times 1.03. That's what we made the previous year, and we get a 3% raise. So we multiply that by another 1.03, which gives us 50,000 times 1.03 squared. So you can see the idea, 2023, 2020 plus 3, 50,000 times 1.03 to the third power. Which gives us how much? Gives us 54,636. .35. So that's our question A. For question B, it says, in what year will they earn 60,000? So how many years will that be? So what is the salary as a function of the number of years? So you can see when we added 1 year, it was 50,000 times 1.03 to the first. When we added 2 years, it was 50,000 times 1.03 to the second. When we added 3 years, it was 50,000 times 1.03 to the third. So if we're going to add T years, so 2020 plus T years, that will be 50,000 times 1.03 to the T, and we want to find out when that equals 60,000, or when that is at least 60,000. So we'll do it a couple different ways. So this is what we need. We need 50,000 times 1.03 T equals 60,000. I'm going to first solve it on the graphing calculator. So let's subtract the 60,000 from both sides. So 50,000 times 1.03 T minus 60,000. When does that equal 0? So again, T is the number of years since 2020. So we'll go ahead and we'll pull that up with the graphing calculator. I need to use X's rather than T's here. So 50,000 times 1.03 to the T power, which will be to the X power here. Then we're going to subtract 60,000 and find out when does this equal 0. Hard to know what zoom to use first here. We want to find out when this thing equals 0. I'll start with zoom standard. and see if that gives me the place where it crisscrosses. As we look. And it does, but you can see that it comes straight down, so it may be difficult for us to find it. But I can certainly get an idea approximately where it is. 1, 2, 3, 4, 5, 6, and a little bit more. A little bit more. So if I look at the table, let's go automatic this time. When do the Y values hit 0? And you can see between year 6 and year 7. So year 6, 2006, we're still a little short of 60,000, but 2007, it indeed does go above 0. So what does that tell us? That tells me that when t equals 7, we're beyond that number. We have reached 0. Just to go ahead and solve it with the 0 finder, I'll adjust my Y values. I need a whole lot more Y than this if I'm going to be able to visualize this. So you saw how big those numbers were. Maybe negative 10,000 to 5,000 with a scale of 1,000. Leaving the X's alone. And I want to see where does it cross. And we'll take a look. And we can see that it crosses there. So to find the 0 finder, to get an idea of what t is, second calc 0 finder. Move the cursor just a little bit to the left of the place where it crosses 0. That's our left bound. Move the cursor a little bit to the right. We expect it to be slightly more than 6, guess. And we get 6.168 approximately. So here we get t is approximately 6.168. So again, years since 2020, so 2026, not quite. So in 2027, they will earn at least $60,000 a year. Now we can also solve that with more typical algebraic strategies. So what are we going to say? Solving it algebraically, we'll say 50,000 times 1.03 to the t equals 60,000. Let's go ahead and divide by 50,000. So we get 1.03 to the t is 60,000 divided by 50,000, which of course is just 6/5 or 1.2. And then what? Well, we can take the natural log of both sides. Natural log of the left, natural log of the right. Natural log of 1.03 to the t equals natural log 1.2. And we can pull the t down in front. And we get t times natural log 1.03 equals natural log 1.2. Dividing both sides by natural log 1.03, t equals natural log 1.2 divided by natural log 1.03. What's that going to give me? Natural log 1.2 divided by natural log 1.03. And I get 6.168. Which is exactly what we received from the graphing calculator. So that reinforces our idea it'll take a little bit more than 6 years. Starting at 2020, the annual salary will finally go above 60,000 in 2027.